Okay, this says point P on the following Ferris wheel will complete one rotation counterclockwise around the circle in 32 seconds. Assume the point is at the bottom of the wheel at t equals 0 seconds. Find the height of the point when t equals 283 seconds, rounded to the nearest tenth of a foot. First of all, it's a pretty small Ferris wheel, but nevertheless. Okay, well, a couple of things we can label right off the bat. It's going at a constant rate, it doesn't say that, but that's implied. So that means we know that, like, if this is at time 0, then by symmetry, this would have to be a fourth of the way around in a fourth of the amount of time it takes to do a full cycle. So that would be 32 divided by 4 would be 8 seconds. And then it's at the top. All right, so we get the time values right away, but we're trying to model height as a function of time. So now it's back here at 32. The diagram gives us enough info for the height. Notice, I mean, this is obvious. If it's telling us that that's 4, we know the radius of the circle is 3. That must mean that that's 3, so that at this moment at the bottom, the height is equal to 1. At the top, the height is 1 plus the diameter, which would be 1 plus 6, which is 7. Here, we're at the same level as on the right, so we're at 4. All right, and now look, I have all the information I need to model this, to model the height as a sine or cosine graph. Some students like to draw something simple. A simple sketch. This is our t-axis, this is our height axis. The time values are 8, 16, 24, 32. And the key heights are 1 foot, and then it's up to 4 feet, and then it's up to 7 feet, and then it's back down to 4. Okay, so I can plot these points, right? At time 0, we're at 1 foot. At time 8, we're at 4 feet. Again, I'm just following these counterclockwise around. At time 16, I'm at 7 feet. At time 24, I'm at 4 feet. And then at time 32, I'm back at 1 foot. So we see this behavior. And now we gotta model this. So we find key things like the midline. The midline is clearly 4. Okay, that's a distance of 4. A couple of other things, we know the amplitude. The amplitude is clearly 3. The period is 32. All of that info can help us write a model. So h of t equals. Now, there's in many ways of doing this. I see this is like an inverted cosine shape. So I don't want to do any horizontal shifts. I'm going to see that as an inverted or upside down cosine shape, which means that I'm not going to put 3. I'm going to put -3 cosine. Okay, now there's no horizontal shift because cosine normally starts on the y-axis, so I don't have to worry about a shift. But my period is 32 pi. That should be 2 pi over b. And that tells me that b is 2 pi over 32, which is fine, but you could also write that as pi over 16. And I have my midline tells me my vertical shift, that's a +4. So here's my model. My model for the height. And we want to plug in 283 seconds. Okay, so this is a clear course where we turn to technology. I have it on Desmos, so let's see what we get. Okay, so we'll just do h of 283. So about 2.3 feet.